Everyone, let's take a look at number 4 in section 4.8 of Achieve. We are given this function here, and we're to calculate the root or estimate the root. Actually, we're going to use Newton's method to do that, and we're going to calculate what we call the first 3 iterations, given an initial estimate or guess of 7. Okay. If we actually go in, let's actually go into the calculator and graph this function real quick. Don't have to do this, but if I go in now, I'm going to graph this. What do I need to make sure I'm going to do? Since there's a sine function, I need to make sure that I'm in radian mode, which I'm in radian mode here. And then I'll enter this in 1 minus 10x sine of x. Okay. And I want to see it. I'm going to go ahead and just do a zoom standard window right now, because we're looking around x equals 7 at any rate. So it's got some ups and downs, as we might expect with a sine function. And since it's being multiplied by 10, it's kind of affecting, 10 and x, it's affecting that amplitude. So we might need to, in order to see this graph, maybe zoom in a little bit, zoom out, up and down a little bit. And I'm going to adjust the window also just to show positive values. So let me go to the window and change the x value to say 0. Actually, I'm going to go to x max of 14. That'll put 7 right in the middle. And then we're going to go from negative 50 to 50 first of all and see what that looks like. Okay, so that amplitude continues to get bigger. It's going up and down, and it's getting bigger and bigger. You can see that going up and down. You can open the window up if you want a little bit more. But basically, this is x equal 1, 2, 3, 4, 5, 6, 7. So somewhere between 6 and 7 is a root. There's actually many roots, but we're trying to find the one here. So you would want to pick something close. And so that's what we're trying to do, actually estimate that root near x equal, 6 or 7. So we're starting with x equals 7. All we're going to do is give the first 3 estimates. Okay. So Newton's method is a method for finding roots to a function, also solving equations, because you can basically set the equation equal to 0 and then find the roots of the side opposite 0. This is Newton's method. So I will give that to you. You'll have that to use. It's an iterative method. Again, you can watch the lecture video for more explanation of where it comes from. But to find the next iteration, we take the previous one, we subtract this expression here, which is the evaluation of the function at that previous value divided by the derivative evaluated at that previous value. Okay. And we talked about in the video where this lecture video where this came from. Okay, so we do need the derivative. I'm going to find the derivative. Derivative of 1 is 0, and then I've got negative 10x sine of x. So I need to use the product rule on that, right? Since I get a negative 10x times the sine of x. So we don't forget that negative's there. So taking the derivative of negative 10x gives me negative 10 times sine of x. And then I've got negative 10x plus a negative 10x or minus 10x times the derivative of sine x, which is just cosine of x. Okay. And so to find the first estimate, x of 1, I use the previous estimate, x of 0, right? So if we're looking at, in this case, n is 0, so this would be 0 plus 1, x of 1, right? So the subscript is just indicating which step in the iteration you're at. So x of 0 minus f of x of 0 over f prime of x of 0. So I've got x of 0, 7, minus, and then plugging into the original function, 1 minus 10 times 7 sine of 7, and then divided by the derivative evaluated at 7, which is negative 10 sine of 7 minus 10 times 7 cosine of 7. Whew, all this stuff to keep track of. And we can simplify, 7 times 10 is 70 here and here. And I notice I've got a negative. I can, we can simplify this, and you're going to use your calculator, obviously, to evaluate this. Now, I'm going to show you the way I did it in the lecture, right? And that is, I'm going to use the old school, the TI-83, the 84 also works this way. But just in the homeschool, what I'm going to do is I'm going to start with my initial guess, which is 7. I'll just hit 7 and hit enter. Okay, just of course copy 7. Now what I'm going to do is I'm going to do the Newton's method next iteration, but I'm going to use the answer key. Remember, the answer key is right above this negative, and what's the value of answer? Well, if I do second and hit that key and I get answer, hit enter, it stores the previous result, right? Whatever the last calculation was, this 7 is now again in the variable answer. So what I'm going to do is the x sub n, everywhere I see an x sub n, that's going to be the answer, right? That's going to be I'm going to use answer in the calculator. So I'm going to do answer minus, and then in parentheses, I've got the function evaluated at answer. So here's the function up here. So this is 1 minus 10 times second answer, right, for x, times sine of answer. Okay, close parentheses on the sign here, and then close parentheses on the numerator, because I'm going to divide all of this. I want that parentheses and that parentheses is the numerator. That's the function f evaluated at, in this case, answer, which is the previous estimate, in this case x sub 0, because I've put answer to be 7, right? And then divided by the derivative evaluated this. So here's the derivative. So I'm going to again put that in parentheses. I've got negative 10. Make sure you use the negative here on the calculator, not the minus sign here. You got to start with a negative. 10 times sine of what again? Answer. Close parentheses on the sign. Minus, now I can use a minus, right? 10 times x, which I'm going to again use answer, times cosine of answer. Close the cosine and then close the parentheses for the denominator. So this is Newton's method. I've done it in the calculator, and this should generate my x sub 1. It's the same thing I typed out here in the calculator. And you might say, why do you go through all the trouble of doing that? Well, we're going to show you. And of course, I did this in the lecture video. Hit enter. There's my estimate. They want it to 6 decimal places, so make sure you round off if you need to. But you don't want to round off this result, as we're going to use this result now, right, to find x sub 2, right? X sub 2 will be x sub 1, which we just found here, minus f of x sub 1 over f prime of x sub 1, right? So this is the next iteration. So how do you do all that? Do I got to type all this stuff in? No. The quick key, right, to help is the entry command, right? If I do second, hit the second button and hit entry, it's going to recopy everything I just typed. And here's the beauty of it. We don't need to do anything to it, because it's now, what's an answer now is x sub 1, right? The 6.241, and it's not rounded at all, which is great. It's going to calculate in the calculator that next iteration, which is 6.29962. 6, notice that 6, right? If I'm rounding to 6 decimal places, I do round this result, but I'm not going to round this off to get my next estimate, right? X sub 3, because I'll just hit second entry, recopy the command, and voila, I have my X sub 3, okay, which rounded off to 6 decimal places is that, okay? If you do this again and hit enter, we don't need this in this problem. The fourth estimate rounded off is the same to the 6 decimal places. You can see there's a little bit difference back here, but you can keep going with this until there's basically no change. Now look at, as far as the calculator's rounding goes, there's no change. So we're, I don't know how accurate you need to be in the problem, but this is pretty darn accurate, right? In a matter of 4 or 5 steps, iterations of this method, we've got pretty much the solution. Okay, so that's the power of Newton's method. Numerical method, very important. Numerical method is very much useful, and probably if you're in engineering sciences, that's more than likely what you're going to be doing, is a lot of numerical methods and techniques. Computer science as well. Okay, hope this helps on this one, and let me know if you have any questions.